Hello everyone, welcome. Today we are building an interactive game called Quantum Bounce. It's a fun dynamic game where a particle bounces around the screen, collecting energy nodes and avoiding traps. By the end of this video, you will have a solid understanding of how to combine HTML, CSS, and JavaScript to create an interactive game. Okay, you can play this game with your friends, and we are going to see in details how this game works and also the conditions for game over. So if you are ready for this game, let's jump in. Here on my desktop, I'm going to create a folder and I'm going to call this Quantum Bounce. If you're on Windows, you can simply right-click on this folder and you will see an option to open with your code editor. If you're on Mac, you can drag and drop this folder into your code editor. And here is our project folder. So let's start by creating the base of our game in index.html file. And with the help of melt, we can use the shortcut to generate HTML boilerplate. So simply type exclamation mark and hit enter. Here, let's change this title to Quantum Bounce. This file will contain a canvas for the game visuals and a score panel to display the player's score. So first, let's add a div, and we are going to give this div an ID of game container. Okay, so and inside this container, we now add our canvas. So here we simply use the HTML canvas. And for this, let's add an ID of game canvas. And after this canvas, let's now add another div. And we give this div an ID of score panel. And inside this div, we now add two span. Okay, one to hold the score and one to hold the level. So here, let's say span. And here, let's say score. Let the starting point be equal to 0. Okay. So let's give this span ID of score. And let's add the second span. Okay. And let's change this one. Instead of score, let's use level. And let's change this to level. So the starting level is going to be 1. Okay. We are going to draw all the game visuals inside this canvas. Okay. Now let's tie the game. So we do this by creating a file here. Let's call this tie.css. So all we want to do here is to simply create a visually appealing background and also format the canvas and the score panel. That's all we want to do. So before we write anything here, let's actually link our style sheet with this index.html. So we can simply do that using the link tags. And here we simply add our style.css. And next, let's actually open this file in a web browser. Okay, good. So here is what we have currently. So let's go to the style.css. And first, let's grab the body and let's set the margin to 0. Let's display flex, justify content to the center. We align items to the center. Let's set the height to 100 viewport height. Let's add a background. So we use the linear gradient. So here, let's put 45 degrees and let's add two colors. So the first one should be, and let's also use, so now we have this background. Let's change the text color. So we set color to white. Okay, also, let's add font family. So we can simply use Arial and sans serif as fallback. Now let's grab the game container, which is the div, the first div. Let's position relative. We display flex. Let's change the flex direction to colon and let's align items to the center. Good. Now let's tie the canvas. Let's set background to black. Let's display block and let's set border to 2 pieces solid, and let's use white. Okay, great. Now let's tie the score panel. Let's add some margin top of 10 pixels, and let's increase the font size to 24 pixels. Let's reduce it to 18 pixels. Next, we need to write our game logic, okay? And for this, let's go back here and let's create another file. Let's call this script.js. So let's link this file with the HTML file, okay? And for this, let's simply put it here. And remember, we use the script tags. And this is going to take an attribute, which is the source attribute. And here we specify the location of our script file. Then because we added this in the head, we actually have to defer this file, okay? Now let's go to our script file. The first thing we need is actually this canvas, okay? So we need access to this canvas. And for that, let's define a variable and let's call this canvas. And let this be equal to document, and let this be equal to document.query selector. Remember, in CSS, for a class we use dots, and for ID we simply use hash. Okay, so we do the same thing here, and we gave this an ID of game canvas. The next thing we need to do is to define the context of the canvas element in HTML. Okay, so we need to get its context objects, which allows us to use a variety of drawing method. Okay, so this is going to give us a variety of drawing method. And to do this, we simply define a variable. Let's call this canvas context. Okay, and let this be equal to canvas dot get context. And in this case, we want to get the 2D rendering context. Okay, we need the 2D rendering context. Let's specify the width of this canvas. So canvas.width, let's set this to 600, and let's also define the height, and let's set the height also to 600. Okay, so now we have this. Now let's define some other variables. So let's define our score to be equal to 0, and the level, let the starting point be equal to 1. Let's define the energy nodes. Okay, so we say let energy nodes, and remember here we are using the let keyword. This is because we are going to reassign, because variables that you are not going to reassign, it's always better to use const keyword and not let. Okay, so let the energy nodes be equal to an empty array. Okay, let's define the traps. So let the traps also, let this be equal to an empty array. Let's specify the game speed. So game speed, let this be equal to 30. Let's define the particle. So let particle, and this should be equal to, so this is going to be an object. So let's define the S coordinates. This should be 300. Let's define the Y coordinates. This also should be 300. Then let's specify the change in S coordinates. This should be 2. And the change in Y coordinates should be 3. Okay. Now we need to specify the size, which is going to be the radius. And let this be 10. And also the speed should be 4. Okay. Now let's declare 3 more without initialization. So we declared these 3 variables without initialization. Okay. So the next thing we are going to do now is to define a function that is going to be responsible for creating energy nodes. Okay. These are collectible items in the game that increase the player's score when the particle collides with them. So let's define this function. So we say function, let's call this spawn node. So first we need 2 variables. The first one for the S coordinates. So let's say const x to be equal to, let's generate some random number. So math dot, and this should go, and this is going to be based on the canvas dot width. Okay, let's do the same thing for y coordinate. So let's y to be equal to, and this should be canvas, and this is going to be the height. Okay, so canvas dot height. Now let's add this to the traps. So traps dot push. Remember, we defined an array here. Okay, this is an array, so we can push items to this array. And here we are going to push x, y, and let's also add the size. In this case, let this be 10. So let's add a comment here. And here we simply say we spawn trap. Next, we are going to draw the particle. Okay, so let's draw the particle, because if you look at the screen, currently we have nothing. Okay, it's actually empty. We need to draw the particle using JavaScript. So we simply call this function draw particle. And here we need access to the context. Remember this context. So we grab the canvas context begin path. So let's access the arc, canvas context dot arc, and here let's add particle dot x, particle dot y. We include the size, particle dot size, and this should be 0, and our math dot pi multiply by 2. So that's going to be the arc. Let's add the fill style. So x dot fill style should be equal to, let's use 0f0. Okay, so let's use this green. And next we need to call x dot fill, and now we have to close the path. So x dot close path. Next we have to draw the energy nodes. So let's add a comment here. We draw the energy nodes. So here let's create a function. Let's call this draw energy nodes. And remember, we defined energy nodes here. So we simply grab the energy nodes dot for each. Okay, so for each node, we want to take the canvas context dot begin path. Also canvas context, just as we did before, we need to define the arc. So we call this arc, and we pass our node dot x, comma node dot y, comma node dot size. We pass 0, just as we did before. And here let's specify math dot pi, and we also multiply this by 2. We also have to define the fill style. So canvas context dot fill style, let this be equal to, let's use ff0, canvas context dot fill, and also canvas context dot close path. And now let's draw the traps. And for the traps, we are going to do almost the same thing we did here. Okay, so let's call this function draw traps, and here we grab our traps dot for each. So for each trap, we want to do almost the same thing we did here. Okay, so we call canvas context to begin path. We can put that here. We also repeat this one. Okay, so we do almost the same thing. We can simply grab this after the begin path, we put that here. Then instead of node, this is going to be trap. So we can change this to trap and trap. Okay, and we now change the style to F000. The trap is going to be red. So whenever we hit this red, our score is being reduced. Okay, so if we hit this red to a specified times, then the game is going to be over. Okay, because actually this is the trap. So it's either we dodge this trap and move on, or we hit this trap, reduce our score, hit this trap until we die off. Okay, so next let's move the particle. So we define a function that is gonna move the particle. So here we say move, let's call this move particle. So particle dot x, this will be plus equal particle dot change in x. Okay, and we do the same thing for y, particle dot y, plus equal particle dot change in y. But we want to bounce off walls. Okay, so when it gets to this wall, we simply want to bounce it off. If particle dot x is less than or equal to 0, or particle dot x is greater than or equal to the canvas width, okay, canvas dot width, we need to multiply the change in x by -1. So we grab particle dot change in x and we multiply this by -1. Okay, so we do the same thing for y. So we can actually copy this line and repeat it here. Instead of x, we change this to y. Okay, let's change this to y. So now let's actually define the game loop. Okay, and let's actually define a function that is going to undo this. So we call this the game loop. And first, we need to get the canvas context and we need to clear the rect. So let's clear rect. The first x should be 0, y should be 0. The width, let's simply use canvas dot width, and also the height, we use canvas dot height. Okay, and now let's actually call the move particle function. Okay, let's also call the draw particle function. Let's call the draw energy nodes, and after this we need to call the draw traps. So let's game interval now be equal to set interval. So we use the set interval function, and let the callback function be our game loop. And here, let's use the game speed. Okay, and let the node interval be equal to set interval, and here we call the spawn node, and let's use 2000 millisecond, 2000. Okay, 2 seconds. And let the trap interval be equal to set interval, and here we need to pass a function. So let's define another function for spawn trap. Okay, and here note this mistake. Actually, here we said spawn trap. This should actually be spawn node, and instead of traps dot push, this should be the energy nodes. Okay, so we are supposed to use the energy nodes dot push. We push our x, we push our y, and let the size be equal to 8. And now let's define another one for spawn trap. Okay, so function spawn trap. So we do the same thing we did here. We can copy this and put this here, and all we need to change here, we change this to 10, and this is going to be traps. Okay, remember we are actually repeating ourselves here. We can use this a single function to undo this and this, because here we are repeating ourselves. We could pass this as a parameter here and also the size. Okay, so we could define a function that takes in the array, the expected array, either the traps or the energy nodes, and also the size. Okay, but for now, let's just leave this. Okay, good. So back here, now we need to specify the spawn trap, and let this be 3 seconds. Now let's actually start this game for now and see what happens. So let's save this file, and we can see nothing. Actually, let's check what is wrong. So let's check the console. You can inspect this. Okay, click on this console, and of course now we get an error. Uncut reference error. X is not defined at draw particle. So let's go to the draw particle and let's see. Yes, here is the problem. This shouldn't be X. This actually should be canvas context. Okay, same thing here. This should be canvas context. Okay, and we see that error is gone. So you see, it's very simple to actually debug and see what the problem is. And now we have this. We are not done actually, because if you look at this, when this particle, the green one, touches any of this node, either the trap or the node, nothing happens. Okay, the score is not increasing. The level is not increasing. There is no game over, nothing, nothing. So next thing we are going to do now is actually to check for collision. Okay, so let's go straight and do that. So after this move particle, let's move this one down. And here, let's actually check collisions. So check collisions. So the first thing we need access to is actually the nodes. So we need access to the energy nodes. These yellow ones, okay, these yellow ones. When the particle touches this energy node, the node will clear off and our score increases. So let's actually access that energy nodes, and we already defined it up. So energy nodes should be equal to energy nodes dot filter. Okay, so we need to filter this energy node. Let's access each node, and for each node, first let's create a variable and let's call this dist, and let this be equal to math.hyped, and this is going to return the square root of sum of square of its argument. Okay, don't stress yourself on this for now. Okay, so here let's now pass the particle dot x minus node dot x, particle dot y minus node dot y. Okay, so the next thing we are going to do is to check if the dist, if it is less than the size of the particle plus the node. Okay, if the dist is less than the size of the particle plus the node, we are going to increase the score. So we check particle dot size plus node dot size. Okay, so if this is true, we want to take the score and we increase it by 10. Grab the score, document dot get element by ID. We gave this an ID of score. Okay, and we want to change the test content. So for now, score is 0. We now want to change the text content, and this is going to be equal to, let's use backticks here. And here we say score, and let's pass the value. Okay, we pass our score. And after this, we simply return false. But here we return true. And now we need to take the trap. Okay, and we are going to filter this traps.filter, and let this be equal to, let's call this trap dist, and let this be equal to math, and we take particle dot x. Here we subtract the trap dot x just as we did for node. Also particle dot y, we subtract trap dot y. Okay, so we need to do similar check just as we did here, So we need to check if it's less than particle size plus trap size. In this case, instead of increasing the score, we are going to reduce the score by 5. And we also need to update the score in the UI. Okay, so we have to do the same thing we did here. So let's grab this here. And after that, we also return false. And outside this, we return true. So now let's call this function and see what happens. So after we move the particle, let's actually check collisions. Let's save this and go back to the game. Watch the score whenever there is a collision and see what happens. Great. So you see now we have 10. Okay. So if it hits the red one, actually there should be a reduction. Now we cannot control this game because we actually have to do that. So we need to use the keyboard event in order to control this game. So let's do that now. So after the game loop here, we can actually add the controls. We want to be able to control the game. Okay. And to control this game on the document itself, we need to add event listener. And in this case, let's add the key down event. Okay. And of course, this is going to take a callback of function. And here we need the events. Okay. So for this key down event, we want to check if event.key, if this is equal to arrow up, or event.key is equal to W. We take particle.dy, the change in y coordinate becomes minus particle.speed. Okay, and we do the same check for arrow down, so we can repeat this. Okay, and if e.key is equal to arrow down, or e.key is equal to x, we want to set particle.y to be equal to, in this case, is going to be positive. Okay, let's also repeat this 2 more times. And here, instead of arrow down, let's change this to arrow left. And this is going to be a, and here x, and in this case, minus particle.speed. And for the arrow right, instead of x, this should be d, and this should be equal to x. Okay, so this is for key down. Next, let's add another event listener for key up. So here we add event listener, and for the key up, we check if the array. So here, let's pass our arrow up, arrow down, w, x. So if this includes our event.key, we simply set particle.dy to be equal to 0. And we do the same check for arrow left, right. So here we change this to arrow left, arrow right, a and d. And this, instead of dy, this should be dx. Great. And here we have arrow down twice. So this is wrong. Let's remove one. Okay. And this should be double R. Okay. And here, this right is actually not spelled correctly. This should be the correct spelling. And everything looks good. Let's actually check what we have. So let's move up. We move down. We move up. Let's move right. You see. Now let's go left. Let's move down. Okay. Now let's go to this red. Move up, move right. Good. You see, everything is now working as expected. Great. So now we can actually control this to actually touch the energy nodes, or actually the traps. Okay. So now we can do anything we want with this game. We can increase the speed. Okay. Great. So the next, we actually need to add the conditions for game over. Okay, so now let's check for game over. So let's define a function, and let's call this check game over. Okay, so let's check if our score is less than, let's say, -10. In this case, we want to alert game over, try again. And of course, we have to clear interval. So we clear the game interval, we clear the node interval, and also we clear the trap interval. And let's go back to our game loop. So inside the game loop, after checking for collision, we need to check game over. Okay, so let's save this and go back to the game. Good. Intentionally, let's actually eat this trap. So we eat the red one, we eat another trap. Now we have -10. Let's try eating another trap. So we see, because the score is now less than -10, we have game over, try again. Okay, good. We also see that the particle moves and bounces off the walls. We check if the particle collides with energy nodes or trap. So if the score drops below -10, the game ends. Congratulations, you have created a fully functional game with HTML, CSS, and JavaScript. You can experiment with the code to add new features like power-ups, timers, or dynamic levels. Let me know in the comments how you want to improve on this game or what you want to learn next. Please do not forget to like, share, and subscribe to this channel. Okay, see you and one love.